assembly language programming with 8051. The very purpose of creating this video lecture is to discuss assembly language programs using 8051. As we know, still today in embedded field, assembly language programming serves a high purpose whenever high time critical and high memory critical applications are there. Because so far, say the assembly language program is only the fastest language which exists in market. Before we discuss assembly language program, say dear students, you remember it is very much important for you to understand architecture, addressing modes and instruction set. So what I do before I start a discussion with assembly language programs, I'll discuss basics which are very much highly required for writing the assembly language programs. So in first two video lectures, I am going to cover the basics of 8051. Later, we are going to discuss assembly language programs using 8051. So basically, say in today's session, I am going to discuss basics of 8051 to start programming. First and foremost, let's have a brief discussion of features of 8051. 8051 has a 8-bit CPU, right? Say which everyone knows it, but what does that 8-bit indicates? The 8-bit indicates it's a size of operand on which we can perform any operations at a time. Like say for example, using 8-bit, if it's an unsigned number, say maximum we get from 0 to 255. Means if it is an addition, we can add two numbers which are maximum of 255. We cannot perform an operation on more than 255. So that's the meaning of 8-bit. Means this 8-bit indicates the size of CPU. Means it is even the size of operand, say on which we can perform any operations. And by the way, what is the meaning of operand? Operand is a data on which we can perform any operations, right? And 8051 has 8-bit bidirectional data bus and 16-bit unidirectional address bus. Okay, say the data bus is used to move the data between the memory and the CPU, whereas the address bus is used to give the address to the memory from the CPU. Because it's say only the CPU will give the address to the memory, say this bus is unidirectional, whereas the CPU will give the CPU can store the address to the memory, and from the memory it can access. Because of that, the data bus is bidirectional. And the next feature is, say the 8051 has got 4 kilobytes. The basic 8051 has got 4 kilobytes of on-chip program memory. Means this is the memory which is available on microcontroller chip itself. And it has got, the basic 8051 has got 128 bytes of on-chip data memory, which is called as a RAM. And even these 128 bytes are grouped into 3 different areas. The first area contains 4 register banks, and the second area contains 16 bytes of bit addressable area, and the third area contains 80 bytes of scratchpad area, which is also called as a general purpose area. More about this we are going to discuss in later part of this video lecture. And there are 2 16-bit timers or counters. Say as we know, these timers and counters are used to keep track of time or the events which occurs internal or external to the microcontroller. And 8051 has got 32 general purpose registers of each 8-bit, and it has got 5 interrupts, of which 3 are internal and 2 are external, and it has got 4 8-bit IO ports. These IO ports are necessary to interface anything to a microcontroller. And 8051 has got 16-bit program counter. Say we know what is program counter. Say it is a special function register which is used to give the address of the next instruction to be executed. Means always the program counter is going to give the address of the next instruction to be executed. And there is one more 16-bit register which is called as a data pointer. Say this is used to fetch the data. Say normally the data whenever we want more data to be stored, in such cases we are going to interface a external RAM. Maximum external RAM we can interface is say 64 kilobytes, because the 8051 has got 16-bit program counter. and even the data pointer is also 16-bit, and address bus is also 16-bit. That's the reason we can address, we can interface 64 kilobytes of code memory and 64 kilobytes of data memory external to the microcontroller. And the data memory can be accessed by using a data pointer, in short DPTR. And 8051 has got a full duplex serial port, which it is going to support full duplex UART communication. And there are many control registers, namely TCON, timer control register, TMOD, timer mode register, mode selection register, SCON, serial control register, PCON, power control register, IP, interrupt priority register, and IE, interrupt enable register. More about these registers we are going to discuss whenever we do some programming using these registers. Okay, so these are some of the features 8051 microcontroller has. And with these features, in short, I am going to discuss architecture of 8051. Because as I told, to begin with programming, we should know the features, architectures, and addressing modes, and lastly the instruction set. So now I am going to discuss the architecture of 8051. So this is the architecture of 8051, where it contains a arithmetic and logic unit called ALU, and this ALU is responsible for all the arithmetic operations. And to do any arithmetic operations, it will take help of normally A and B register, and A register is also called as accumulator. And you know why the reason of calling A register as accumulator, because most of the operations, after performing most of the operation, the result will be stored in a register only. Because the result is always accumulates in A register, it's called as a accumulator. Okay, and it has got a PC, which is a program counter. So it is responsible for giving a 16-bit address, which is interfaced to, so which is connected to ROM. And say there is a DPTR. DPTR is a 16-bit register, but which can be divided into two 8-bit registers, namely DPH and DPL. And there is a program status word. Say in short, it is called as a PSW. PSW is used to store the results of some operations, so which I am going to discuss later in detail about the PSW. And so there are many special function registers in ROM, some of which I have named in features. And this is a ROM, so normally it's of 4 kilobytes, and this is of 128 bytes. And these are the 4 ports, so port 0, port 1, port 2, and port 3. And say this is a internal RAM structure. 4 register banks are there, namely bank 0, bank 1, bank 2, bank 3, and afterwards we have a byte and bit addressable area, say which will be of 16 bytes. And later what we get is above this we have a general purpose area, and these are the special function registers. Okay, so anyhow, say more about the RAM and say ROM, even the special function registers we'll discuss in the next session of this video. This is a small details about the architecture. I want you to go through this again and study everything in detail. So as I told, we are going to discuss a program status word, because it is very important for the assembly language programming. The size of program status word is, it's a register whose size is 8 bits. And the why it's called as a program status word, whenever we are going to execute any operation, the result of that operation, the status of that operation will be reflected in this register. Like say for example, if we add 2 numbers, whether that addition is resulted into a carry flag or not, and whatever the say accumulator content is there, whether it contains a even parity, odd parity, everything can be stored in this particular say register. Because of that, it is called as a program status word or program status register. So the basic and important flags here are, the first one is parity flag, which it is going to tell whether the content of accumulator contains a even parity or odd parity. Odd parity means the number of ones in accumulator should be odd number. Even parity means the number of ones in accumulator should be even number. Right? Say then say this B1 is not used. This is reserved for future use. And B2, the bit say 2, this is a overflow flag. This overflow flag will become 1 whenever there is a bit out of B6 to B7. Basically, say this overflow flag we are going to use in signed operations. And B3 and B4 combinedly is going to serve a purpose to select the register bank. As I told, there are 4 register banks, namely bank 0, bank 1, bank 2, bank 3, and at any time only bank 0 will be active, because say remember by default on power on reset B3 and B4 bits will be 0 0. Because of that the bank 0 will be active. If at all we want to select bank 1, we should set RS1 and RS0 as 0 and 1. If at all we want to select a bank 3, say for example, both we should set to 1 1. This can be done by say using a bit set and reset instructions. Next is here say F0. F0 is a user flag 0, say which is meant for user purpose. More about this we are going to discuss in later part of the programming. And ACE stands for auxiliary carry. This bit will set to 1 whenever there is a bit out of B3 to B4. In doing a addition operation, say for example, if there is a carry from B3 to B4, then auxiliary carry will become 1. If there is no bit from B3 to B4, then auxiliary carry will be 0. And lastly, this is a carry flag. So the carry flag is set 1 if there is a bit out of B7, and it is set to 0 if there is no bit out of B7. So normally the carry flag will be used in case of addition and subtraction instructions. And in case of subtraction instruction, the carry flag is also called as a borrow flag, means it will serve the purpose of borrow. Now we will discuss the internal RAM in detail, how the RAM is organized. Yes, this is a RAM structure. See here, it will start with address 0. The RAM contains, as I told, 3 different areas. The first area is a bank area, the second area is bit addressable area, and the third area is general purpose area. The 128 bytes are divided into 3 different areas. In the first area, we have a working resistors or general purpose resistors. Those there are 32 general purpose resistors which are grouped into 4 banks. In bank 0, bank 1, bank 2 and bank 3, every bank contains 8 resistors, and the name of those resistors are R0 to R7, bank 0. Similarly, R0 to R7, bank 1, R0 to R7, bank 2, R0 to R7, bank 3. So, whereas the address will start with, say for bank 0, the R0 address is 00 and R7 address is 07. For bank 1, R0 address is 08 and R7 address is 0F. For bank 3, R0 address is 10, whereas R7 address is 17. And lastly, for bank 3, R0 address is 18 and R7 address is 1F. So this address is a hexadecimal address. Okay, so from 00 to 1F, there are 32 address locations, means there are 32 general purpose resistors. These resistors can be used for temporary result and even some of the data while doing the operations. But remember, by default only bank 0 will be active, means by default if you write any instruction inside that some resistor anywhere between R0 to R7, those resistors will be accessed from bank 0 only. To select any other resistor from different banks, we are supposed to use RS1 and RS0 of program status word. And next is, so after 1F, what we get is 16 bytes of a bit addressable area. Remember, say these working resistors we can address only a byte, means directly we can address 8 bits. We cannot address a single, we cannot access a single bit from this. Whereas this 16 bytes of area is a bit addressable, means from this we can fetch a single bit, not even a say a whole byte. Instead of that single bit we can address. Bit addresses have been shown here. This is a 0, which is a bit address. Next will be 01, 02, so on to 07. Because it's a 8-bit area, say this is 00 to 07. Next address will be 08 to 0F. Next 10 to 17, so on to the last address will be, last address set will be 78 to 7F, which it has got totally 16 into 8, because these are 16 memory locations and every memory location got 8 bits in that. Say we have a totally 16 into 8, which is equal to 128 bits of bit addressable area we get, or 16 bytes of a bit addressable area we are going to get. How to use this bit address and how to fetch bit in this, that we are going to see in a programming part. And the lastly, after 2F, what we get is 30. From 30 to 7F, all are general purpose or scratchpad area, say which is used to store any data in it. Okay, to fetch this area means to access this area, we are going to use some direct addressing. So that we are going to see different types of addressing modes we are going to see later. RAM organization, as I told, 128 bytes is divided into 32 bits GPRS, means general purpose registers, 16 bytes of a bit addressable area, and 80 bytes of scratchpad area. Okay, so with this we'll proceed further to discussion of internal ROM. Internally, the 8051 contains 4 kilobytes of ROM whose address starts with 0000H to say 0FFFH, triple FH. Here, so the first address in a ROM can be accessed by say 4 zeros, and the last address, because it has got 4 kilobytes of internal ROM. Remember, this is a basic microcontroller. Whatever the features I am discussing, it's of a basic microcontroller. There are variations. There are so many variations to this basic microcontroller. Whenever I am going to discuss a interfacing part, there we'll work with a actual 8051, and during that time I am going to tell which are the features available in that particular microcontroller. But say the basic microcontroller has got these features which I am discussing now. Okay, the first memory location is 0000 and the last memory location address is 0FFH. Okay, the size of every memory location is 8 bits here. Maximum of 64 kilobytes of external memory can be interfaced. If this memory is not enough, say we can interface a external memory, so that maximum memory size will be 64 kilobytes. Okay, so whose address range in such case will be say 40 to 4FH in hexadecimal. Right, so now we'll move on to pin details of 8051. So dear students, so if you don't know some of the parts properly, you study it before we start the programming part. So here the pins of 8051, so we know that 8051 is a 40 pin IC. Normally we get in a dual in package or quad in package. Okay, so this is a pin diagram which is got a dual in package type. This is a notch. When how to recognize which particular pin is one, so there will be a notch here, and normally there will be one dot this side, and wherever the notch and dot will be there, from that it's a pin number 1, and from that to last it is pin number 20, later 21, and this is 40. Okay, it's a 40 pin IC where say you can see these are all port 1 pins, and here port 0 pins are there, here port 2 pins are there, and here port 3 pins are there. In port 1 we have not written anything like RxD, TXD, INT0, something like this, whereas in other like port 3 we have written some. What's the meaning of this? Remember dear student, so this 8051 pins are multifunctional. Like say here, if we consider port 3, say these pins is going to serve, apart from normal input output operations, they'll serve some other purpose. Like say P3.0 is used for RxD, it's called as a receive pin, and P3.1 is for TXD, transmit pin. This normally RxD and TXD are used for serial communication. More about these pins we are going to discuss when we start the programming. And so this external 1 and external 2, so these are used for interfacing the crystal to the 8051. In short, I am going to discuss about the pins of 8051. 8051 is a 40 pin IC. It operates on 5 volts power supply, and there are 4 8-bit IO ports, namely port 0 to port 3, which is going to give total of 32 IO pins, and many pins are multifunctional as I have shown. P0 has data bus multiplexed with low order address bus. Yes, P0 port 0, apart from normal IO operation, it can be used as a data bus, and even it can be used as a low order address bus. Pin 1 to 8, say these are the port 1 pins, can be used as a simple bidirectional IO port. And pin 9 is a reset pin, so normally it is used to reset the microcontroller. And pin 10 to 17, say these are the port 3 pins, all port 3 pins are multifunctional. Okay, you can see the pin diagram where I have shown all the functions there. And pins 18 and 19, these pins are used to interface the crystal for clock system. And pin 20 and 40, pin 20 is ground whereas 40 is VCC. And pin 21 to 28, these are the port 2 pins. So these pins can be used for simple IO operations, and even the port 2 pins is going to serve as a high order address bus, because port 0 is going to serve as a low order address bus and port 2 will serve as a high order address bus. And pin number 30 is used for external access pin and is used to enable or disable external memory interfacing. Whenever there is external memory, if at all we want to access from the external pin memory, say we are going to use EA bar, this particular pin. This is very important if at all we are using a external memory. Then pin number 31, so this is a address latch enable pin. So it is used to demultiplex, as data bus and address bus are multiplexed. So this pin number 31, which is called as a address latch enable pin, it is used to demultiplex the address bus and data bus. Finally, pin number 32 to 39, these are the port 0 pins. So these pins can be used as simple IO port, data bus and low order address bus. This is a brief introduction about the 8051. I have discussed the features and architecture details, pin details of 8051. With this, we'll stop here, and in next session, I am going to discuss the addressing modes of 8051. Hope this is clear to all of you, dear students. Thank you. Thank you for watching.